Okay, welcome back. We're at the beginning of chapter 15. We're looking at the nature of the solar system and broadly in the area of astronomy. And in this short lecture, we're going to look at the ancient astronomy, primarily the astronomy of the ancient Greeks and Egyptians, and see how it influenced all the way up, especially up until the Renaissance. So the first thing that I remember as I'm studying this or looking at this really ancient time is they didn't really follow very much the idea of what we think of as the scientific method. They were more philosophers. So the Greeks prided themselves in their ability to think and really think well. And some of the most brilliant ideas that man has ever come up with in that region at that time. But in terms of what they saw, it was hard to measure things. It was hard to methodically go through. So they argued philosophically for some of their ideas. For instance, they saw that the Earth doesn't move, that the Earth is stationary and still. There is no evidence to them that the Earth is actually in motion. So when you have motion of the stars must be moving. If there's motion of the planets and of the sun, then it's the sun and the planets that must be moving. It took a long time, and a lot of people argued for centuries over these ideas. So the first thing they had is the idea that the Earth was stationary, that the Earth was created for man, and for that reason, everything around the Earth was almost a show. It was a powerful place. The heavens were where the gods lived. So the Earth was geocentric. The Earth was at the middle of the universe. Now, because the church also held the same view, as it went from pagan times into Christian times, the church wanted the idea that the Earth was the center. They did not like the idea that the sun could be the center, as it was later argued. So a geocentric view was that you had a motionless Earth, and then the celestial bodies would rotate around in a fixed time around the Earth. The stars would move, and you also had the planets would move. Also, you had this idea of geometry. The Greeks loved geometry, and for that reason, everything kind of wanted to go in circles. And for ages, nobody wanted to resist this idea that everything goes in circles. So you had a circular sphere around the Earth. All of the planets were to have traveled somehow into circles. All of the sun traveled in circles around the Earth. And so that perfect geometric shape was very important philosophically to them, and they held on to it a long time. And some of their theories to explain the abnormalities of what they saw in the sky was based upon the fact that they really, really were holding tight to this idea of circular forms. Okay, so when the Greeks looked up at the sky, or these ancients looked up, the stargazers looked up at the sky, they noticed that the star constellations are always relative to each other. So if they looked up and saw the bear always looked the same. The stars were always in the same proportion, the same distance away. They were in the same place in the sky every night. The stars rose, the constellations rose, they went over the sky and they set. They rose in the east and set in the west, just like the sun does. And they noticed that the sun also moves, but it's not always in the same place. The moon would rise and set, but the moon was not always in the same place. And there were also 5 planetoid. In fact, the sun, moon, and these planets were called planetoid because their Greek means wonder. So it's like they just wandered around the sky. They didn't stay in the same place like the stars. So their idea, their argument, their theory was that the stars were fixed to some kind of a transparent dome, very, very high up, away from the Earth, and that they rode kind of like lights attached to a ceiling. And they just followed that same pattern. but the planets and the sun and the moon could just wander at will around. Now they realized later that they follow the same path, so it's not exactly like that they're just going where they want to, but they are not sticking with the constellation that they're in. So for instance, the sun might be in one constellation one month, and then the next month moves over into the following constellation, and we'll see later that develops into the zodiac, where the sun is riding in these constellations in various times. In this slide, we have a very interesting ancient theory. Okay, this is a theory that was held by people for 1,000 years. It had a lot to do with the fact that the geometry of the circle was very important to the Greeks, and it also held to the idea that these planets didn't always ride or in the same part of the sky. So they didn't take nice smooth paths, but they kind of bent around. You would have them kind of rush forward for a few nights and then kind of slow down. Then they'd go backwards for a few nights. Okay, we'll see that that's called retrograde motion. So as you're plotting Jupiter, you're looking at Jupiter, you can see it tonight, you can see it tomorrow night, you can see it the next night, but as it's plotting its course across the sky, it's not like it's on a road going in a straight arc or a straight line. It tends to kind of speed up and slow down and go backwards and go forwards. And in order to explain this, they had ideas called epicycles, where each of these planets would kind of go in circles as it was going in a big circle. You remember, they had these orbits that in their mind had to be circular, so you could go in big circles, but also little circles inside of big circles. Notice that the sun was one of these planetoid. So you had the moon, which would go around, you had Mercury, Venus, Mars, Jupiter, Saturn. Those are the 5 planets that were known in the ancient times. And then the sun also would rise. The sun needed to be farther away than the moon. The moon seemed to be bigger than the sun was. The disk of the sun usually was small. So it made sense to them. It explained things. Problem is, because it was not right, it doesn't explain things perfectly. And so all of these kind of little annoyances where the theory didn't perfectly match what you saw bugged people for centuries, and during the Middle Ages, this was finally ignored. So retrograde motion is when these planets seem to go forward and then stop and then go backwards and then stop and then go forwards. So retrograde means against, backwards is the idea of it, backwards. So Ptolemy was a Greek mathematician, proto-scientist, early scientist, very, very smart guy. He was actually Egyptian, but when ancient Greece owned this part of the world, and he, in his writings, wrote about these large circles and the circles inside of circles. So circles spinning around and round as it went around the Earth. And this was called epicycles, or he called it epicycles. And this was held, for 1,400 years. Everybody held to this because Ptolemy was so smart. This is the idea of the epicycle, what we see, all right? Now, the best thing I can explain is that Mars is farther away from the sun than the Earth. Now, we're back in our idea of the solar system where the sun is the middle, the Earth is at a distance from the sun, and Mars is farther away. So imagine that you're running track and you have the inside lane, all right? That's wonderful. I love the inside lane because you can go the same speed, but because that is a smaller distance, you can actually end up going faster. So if two people are driving on the interstate and the inside lane and the outside lane is going the same speed relatively, the inside lane will start speeding up. It appears that we're going faster. So watch at the same time. You've got the Earth going on the inside lane, Mars on the outside lane. If you look at Mars from the same spot on Earth, you're going to see, look at the pink lines there, what appears is that Mars keeps going in the sky, in a distance, and then it stops. And then it turns around, and then it stops, and then it goes forward. This is the idea of retrograde motion. And this is what bothered people about the epicycles, because it didn't perfectly describe what was being seen. As soon as you realize that what's causing the epicycles is not that Mars is going around in a circle as it's going around the sun, but this fact that the Earth is simply on an inside track, and because it has a smaller distance to go, it appears to cover that distance in a smaller amount of time. Here is the Ptolemy's idea of retrograde motion. If it's going around in a circle as it's going around the Earth, remember this is the old idea where you have a geocentric, the Earth is in the middle and the planets were going around them. I think he's brilliant, because it did have this idea that if with this idea you could go forward, stop, go backwards, stop, and go forward again. It just didn't match perfectly. And because people thought it was such a great idea, it was such a brilliant thing, they held on to it for hundreds and hundreds of years, even though it did not match what people actually saw when they looked up in the sky. So there was a bias here. There was a prejudice that these people that taught me must be right, and they can't be wrong, and so we just have to hold on to what I've been taught rather than look at the evidence. So that's, I guess, a lesson for all of us.